Hello and welcome to the PS08 assembler software screencast. My name is Ralf Emberger and I will guide you through this small introduction. The main goal of this cast is to provide you the basic knowledge of how to operate the assembler software in order to get you started quickly in developing programs for the PS08. The PS08 is the latest product of our PICOSTRAIN series, the product line for measuring strain gauges with an innovative measurement principle. What I will show you in this screencast is the following. First, installing the software and driver for the programmer. Second, I will explain the elements of the graphical user interface. This includes the windows, menus and bars of the software. Third, I will write a simple example program in order to show you the basics of the PS08 assembly language and how to compile and build a program. Afterwards, I will demonstrate as point 4 how to download the program and make sure that it was successful. For some first examples, we have an integrated examples dialog box which can be used as a good starting point for developing your own programs. I will show you how in point 5. At last, we will have a look at the integrated online help which provides further information for you to go on learning more about the software. The PS08 assembler software package can be downloaded from the acam website free of charge. Please see the link on this sheet. After downloading, please unzip the package and run the setup executable. You will see the startup screen of the installer assistant which guides you through the installation process. On the sheet to select the installation path, we recommend to use the default settings. After accepting the license agreements, you can install the software by pressing the next button. Eventually, you will be asked to restart your computer after the installing procedure. After the software installation, please start the PS08 assembler software and plug in the programmer afterwards. The operating system will ask you to install the driver for the programmer. Follow the installer assistant by selecting the options shown on the screen. Please select the driver from C Windows System 32 Driver folder. After following the driver installer assistant, the device should be installed properly and be ready for use. This is also indicated by a balloon window from the operating system. You can double-check proper installation in the Windows Device Manager, where the programmer should appear as PS08 under PGR device. From now on, the package is ready for use. In the next section of the screencast, I will explain the graphical user interface and how to perform actions. When you start a PS08 assembler software, the graphical user interface comes up with a menu bar, a toolbar, and several tabulator windows, as well as the exit button on the left bottom corner. In general, the important functions are normally available directly in the tabulator pages, for example on the first tab page, the compile, build and run buttons. But nevertheless, you'll find all the available functions of the assembler in the menu bar. The menu is divided into the sections File, Edit, View, Assembler, Debugger, Download, Tools and Help. By clicking the menu items, a submenu is shown where you can select the functions directly. The functions themselves will be explained in combination with the assembler later on. The toolbar here is mainly a subset of the functions available from the menu bar. In other words, the most important functions are accessible from here. Those are file managing functions, editing functions, assembler and debugger functions, as well as 4 special buttons which you find at the end of the toolbar. One of the special buttons is the Chinese flag, which already indicates that you can switch the language of the graphical user interface by pressing this button. All controls and also the menu is shown in Chinese characters then. You can switch back by pressing the same button again, which is now showing the British flag to indicate the English version. Another special button labeled with tools is indicating the tool settings dialog box. By pressing this button, a dialog box comes up showing some configurable options, like activating syntax highlighting or line numbering of the editor, or particular options for the debugger, but also some general window settings. You can set the options active by pressing the Apply button, or close the dialog box without any changes. Besides the menu and toolbar, the user interface is mainly dominated by the tabulated pages. The 4 tab pages are Assembler, Includes, Debugger and Download. As the label suggests, the Assembler editor is located on the Assembler tab page, where the include files are rolled out on the second tab page. You can download the compiled program on the Download tab page, and afterwards you can debug the program with the debugger interface found on the tab page 3. As I will explain the several tabulated pages when it comes to the dedicated functions, let me start with the Assembler tab page as the first item. The tab page is divided mainly into 3 areas, where you find above the source code editor, below the buttons to operate the assembler, and at last the message output window at the bottom. At first sight you already see that the editor itself comes with line numbering and syntax highlighting functionality, which makes writing a program comfortable. This leads me to the next item, where I will show you how to write a program. In the following section I will show you general features of the source code editor, how to write a program and how to operate the assembler. By pressing the very left button on the toolbar, a new assembler file is created. This file only contains a few comments so far, which you can use to fill in some information about the file itself, for example the name of the program, the author or the date. A multiple-line comment can be introduced by using the labels comment and end comment embedded in a smaller and greater character. So it is possible to structure your program clearly and to make annotations which increase the readability of the code. To save the file, please click on the floppy disk icon in the toolbar or use File, Save in the menu. In the folder Examples you find a subdirectory My Examples, where you can save the assembler files. Of course you can choose any other folder to store these files as well. As the PS08 needs to be configured, we include the register settings at the very beginning of the program. This is usually done by including a header file which contains the configuration for the PS08. This way the configuration can be adapted easily and reused in other programs. To include a file there are 2 measures needed. The first one is to open or create an include file on the Includes tab page. I will open an existing configuration by pressing the button Open Include File. The header file is stored in the sample header folder in the PS08 assembler software main directory and is called config.h. The second step to include the file properly is to use the include directive in the assembler program. In this case you would write #key, the keyword include, and the name of the header file in apostrophes, which is config.h here. That's all that is needed to include a header file. I will do the same now for an include file called getButtonEdges into status.h, which is necessary every time you're going to write a program that uses buttons. The include file can be found in the directory sample header again and also in the example directory. After including the header files, we are now coming to writing the program itself. I will write a sample program to show the way of programming and the possibilities in general. You can use constants by using the keyword const in capital letters, followed by the constant's name and the corresponding number. for example myConstant5. Later in the program you can use myConstant as placeholder for the number of 5. What you can see already is that the syntax highlighting is applied automatically and that it increases the readability of the code. The syntax highlighting is also applied when it comes to the use of opcodes. The opcode is not set to bold until it is recognized as valid opcode. For example, clear stays in normal 4 until the word clear is completed. This way it is very easy to know if the opcode exists or not. Also the parameters are highlighted accordingly as far as the opcode has parameters. For example, the opcode move x,20 has 2 parameters and they are both shown bold. An overview about all available opcodes you can find in the integrated online help, which opens up by clicking the green link here or pressing F2. In the opcode help you find several categories of opcodes where they are listed one by one. By clicking one of them, a detailed explanation as well as some examples are shown in the lower window. This helps a lot at the beginning to get familiar with the opcodes. Many of them, like clear, add, move, and so on, are very similar to the opcodes in other assembly languages. Besides the common ones, there are also some very special and powerful opcodes, like conditional jump opcodes or the number to LCD opcode, which shows a number directly on the LCD out of an accumulator without a need to do any conversion previously. As the online help is based on the Windows help system, you can let this window open in parallel to access it quickly during the development process. Well, to go on with the program, I now add some more lines of code. The inserted line to firstly clear the accumulator X, afterwards the value of 20 is assigned to it, and in the third line, the value of 5 is added by the add opcode by using the constant which we defined previously. That means the accumulator X has a value of 25 now. Let's go and show this value on the LCD display with the next lines of code. Therefore, the dedicated opcode number to LCD is used. Number to LCD assumes the value to show in accumulator X, where the second parameter defines the post-decimal position. In this case I choose it to 0, so that 25 without comma will be shown on the display. To update the LCD display, the opcode new LCD is needed in combination with number to LCD. At the end of a program, it's obligatory to insert the following 2 lines: CLR-WDT to clear the watchdog timer and stop to make clear that this is the last command of the program. So now we are ready to compile and build a program, which is simply done by clicking the 2 buttons Compile and Build one after the other. The button Run does combine the 2 steps in only one. In the message window you can see the messages from the assembler. If the exit codes are 0 and the message ASM1 respective ASM2 processing was successful, everything is fine. In this case the corresponding hex file is generated, which is also set in the message window. Just for demonstration I show you now how to work with the message output window in case there are errors in the program. For this purpose I delete the second parameter of move x,20, which is of course obligatory with this opcode. If I press compile now, you'll see that the compiling is not successful and an exit code is generated. There is also an error message given which says syntax error occurred in line 23. It also says the number of parameters for this opcode is incorrect. So we know that there must be something wrong in line 23. We can correct the error in this line and try it again. Now the compiling and also building succeeds again. This way it is possible to correct errors in the program. As we wrote a simple program now successfully, we can download the compiled text file to the PS08. I will show you how to do this in the following section. First of all, we switch to the Download tabulator page, where we find all the controls needed for downloading a file. We can see already that the hex file is displayed in the upper window, ready for the download. To make sure that the programmer was installed correctly and that we have a proper working connection, we can check the status by pressing the button Get Device Info. In the lower window there appear messages which are related to the USB interface, so we can see in this case that one device was found, what means that the programmer is ready for use. By pressing the button Download Hex File, the download begins and the current status is indicated by the lamp on the right hand side, where some status messages like failed or success are shown. So you can see within seconds whether the download was successful or not. If it wasn't, you'll find further detailed messages in the message output window. In case it was successful, it is recommended to press the Read and Verify button. Only if this verified read shows also success, we know that the program was written correctly. In the case of our sample program, we can see the number of 25 now displayed on the LCD. In general, hex files can be selected directly when they were already compiled. By pressing the button Select Hex File, a file selector comes up where you can choose the hex file. Once loaded this way, the file can be downloaded the same way as shown previously. As you know how to download programs to the PS08 now, I will show you in the next section how to do this with the examples included in the assembler software. First of all, you find a similar example to the one I wrote in the screencast in the help menu by clicking the item Getting Started Example. This example is very simple too and does show the word good on the LCD display after downloading it. You can use this example to get familiar with the assembly language and to play around on your own. In a second step, I recommend to have a look at the integrated example collection. By clicking on Search Examples in the Help menu or simply clicking F4, a new dialog box comes up. In this Search Example dialog you find three sections: the Basic Examples, the Scale Examples, and the Advanced Examples. In every section you can click on the example in the example tree on the left hand side and you will see the example's description on the right hand side. The nice thing is, if you click on the button Open Example, the corresponding assembler listing with all needed include files is opened and ready for compile. After compiling and downloading the example, you can operate the program directly with the I/O buttons on the motherboard of the evaluation kit, or you can use the soft buttons on the debugger tabulator page. Please note that in case you want to use the hardware I/O buttons, you need to unplug the SPI connector. I will operate the multiple buttons example with the soft buttons now. Although they are located on the debugger tab page, they work independently from the debugger. That means in case the debugger is active, you can use the buttons for debugging of course, but you can use them also without being in debugging mode. So this example shows the number of 8 on the display after pressing the reset button. By pressing the button IO0, another digit of 8 is added. The button IO1 resets the LCD display to 1 digit again. By pressing button IO2, the multiplexing of the LCD is changed. In general, this example was written to show the use of buttons and how you can react in the program after button was pressed. Just play around with the example to get more familiar in programming with the PS08. I will open another example now and show you how to download it to the PS08 in only 2 steps. Therefore, I open the Search Examples dialog again and select the LCD counter program from the Basic Examples section. After the program was loaded, I press now the arrow button in the toolbar. This is the button for running the compiler. Afterwards, I simply press the button next to it to download the file to the PS08. You can see this way it is very easy to compile and download the program. The loaded program simply shows an upcounting number from 1 to 100 on the LCD display. Of course, the basic examples show, as the name already implies, only some basics of how to program the PS08. If you think about weighing scales application, the scale examples are the next step to take. The simple measurement examples, I select the example with the median filter here, are a good starting point for developing programs for your own application. Once compiled and downloaded, the program can be switched from sleep mode to the measuring mode by pressing button IO0 on the debugger tabulator page. The offset is determined and subtracted so that 0.0 kilograms is shown at the beginning. By charging the load cell with 1 kilogram, we can see the measurement value on the LCD display. In the program there's already a tare function integrated, so that pressing the IO0 button again resets the value to 0 and you can charge the load cell again, for example with 100 grams. Of course this example is not a perfect scale program, but as simple fast step filter and hysteresis was built in already, it's well suited to be used as a good starting point for writing your own scale programs. By pressing the reset button again, the program switches to sleep mode, where current consumption is reduced. As demonstrated in this section, the search examples dialog can be very helpful for first steps with the assembler software. By the way, we here at Acam are working steadily in optimizing the existing examples and writing new ones. Please check regularly at our website www.acam.de if there are some new examples available. In the last section of the screencast I show you the integrated online help, which is the third component in the help package next to the opcode help and the search examples dialog. The integrated online help gives you a helping hand in getting familiar with the assembler software. You can open the general online help by clicking on Help Contents in the Help menu or simply pressing F1. The help file comes up in a new window which is like the opcode help based on the Windows help system. The general online help gives you further information about the details of the graphical user interface and the assembler itself. On the left hand side window you find a table of content which allows quick and easy navigation. The two main chapters, user interface and assembler, do have a lot of sub-chapters where not only the functions are explained in detail, but also some background knowledge is given, for example how the assembler works internally. Many topics which I already introduced in the screencast are found in the general online help too, so that you can take your time to read these points you are interested in without any hurry. In this context I want to point out especially the programming tips which are found in the assembler chapter. On this page you find some useful tips for writing good assembler programs and to avoid already known difficulties in writing programs for the PS08. This section will also be updated steadily as new insights are gained here at Acam. Of course you can use the general online help as well as the opcode help in parallel to the assembler, as it is opened in a new window which can be minimized and maximized as usual. After telling you now at last about the integrated online help, I'd like to come to the end of the screencast. I think we covered a lot of topics regarding the use of the PS08 assembler software, so that you can now start to make the first steps on your own. For these first steps I wish you good luck and success. At last I want to say thank you for watching the Acam screencast about assembler software and say goodbye until the next time.